The carbon cycle. The carbon cycle depends on photosynthesis and aerobic respiration by Earth's living organisms. Carbon dioxide, which is CO2, enters the atmosphere and is the major contributing compound for the carbon cycle. Management of the carbon cycle is the focus of global warming. CO2 enters ecosystems via photosynthesis. Respiration, deforestation, burning of fossil fuels, and forest fires are the processes that put CO2 up in the atmosphere. Diffusion of CO2 into aquatic systems from the atmosphere allow carbon to get into aquatic food webs. Here, decomposition puts carbon into sediments. And finally, compaction over time turns the carbon within the sediments into fossil fuels such as coal. The nitrogen cycle. The major reservoir for nitrogen is the atmosphere. The chemically unreactive nitrogen gas, which is N2, makes up 78% of the volume of the atmosphere. Lightning and certain special bacteria in the roots of plants can fix nitrogen from the atmosphere. Ammonia, which is NH3, ammonium, which is NH4+, nitrite, which is NO2-, nitrate, which is NO3+, are the major sources of nitrogen in the soil and aquatic systems. Burning fossil fuels, the use of fertilizer, the action of anaerobic bacteria on livestock waste, and the destruction of forests, wetlands, and grasslands are ways humans interfere with the nitrogen cycle. Natural processes like volcanic activity can also put nitrogen oxides into the atmosphere. Nitrogen fixation is the combining of N2 gas with hydrogen to make NH3, in which some is also converted into NH4+. Ammonification is the conversion of detritus into simpler nitrogen-containing inorganic compounds NH3 and NH4+. Nitrification is a two-step process in which special bacteria convert NH3 and NH4+ into NO2- and NO3- for the use by plants. Denitrification is the conversion of NH4+ and NH3 back into NO2- and NO3-, and then into N2 and N2O, which releases into the atmosphere. The phosphorus cycle. The major reservoir for phosphorus is phosphate salts containing phosphate ions in terrestrial rock formations and ocean bottom sediments. The phosphorus cycle is slow compared to the water, carbon, and nitrogen cycle. Phosphorus is transferred by the means of the food web. It is a component in nucleic acids, ADP, ATP, bones, and teeth. Phosphorus is also often the limiting factor for plant growth, unless it is applied as fertilizer. It is also the limiting growth factor for producer populations in freshwater systems and lakes because it is only slightly soluble in water. Humans are likely to interfere with the phosphorus cycle by extensive mining of phosphate salts, heavy use of fertilizer, and poor management of sewage. Erosion and runoff are the major transportation means of phosphate into aquatic systems. The rock cycle, the slowest of Earth's cycles. The Earth's crust consists of mostly minerals and rocks. Most of more than 2,000 identified materials occur as inorganic compounds formed by various combinations of elements. Sedimentary rock is made of sediments, dead plants, animal remains, and existing rocks that are weathered and eroded into small particles. Some examples include sandstone, shale, dolomite, limestone, lignite, and bituminous coal. Igneous rock is made of liquid magma that wells up from the upper mantle or deep crust, then cools and hardens, and it forms the bulk of Earth's crust. Some examples include granite and lava rocks. Metamorphic rocks form when pre-existing rock is subjected to high pressure and temperatures, chemically active fluids, or a combination of all three. These forces change the physical properties, appearance, and reshape the crystalline structures. Some examples include anthracite, slate, and marble. The sulfur cycle. Most of the sulfur on Earth is stored in rocks and minerals, including sulfate salts buried deep under ocean sediments. Sulfur also enters the atmosphere by anaerobic decomposers producing hydrogen sulfide and volcanic activities releasing sulfur dioxide. Sulfur particles such as ammonium sulfate enter the atmosphere from sea spray, dust storms, and forest fires. Sulfate ions are an essential component of many proteins. Humans interfere with the sulfur cycle by burning and refining fossil fuels, burning coal, and smelting metals, which release sulfur dioxide into the atmosphere. There is also oxygen-deficient, environment-specialized bacteria that convert sulfate ions and sulfide ions. These sulfide ions react with metal ions to form insoluble metallic sulfides, which become deposited as rock, allowing the cycle to continue. The water cycle. Water can be found in the biosphere, atmosphere, and especially the hydrosphere. It can be found in all three of its forms, which would be solid as in ice, liquid as in plain old water, and gas as in water vapor. The biosphere contains plants and other life forms, and within it, water is a crucial component and partakes in transpiration. The atmosphere contains water in the forms of vapor, one of the stages before precipitation. The hydrosphere is literally all about water. It includes Earth's largest and smallest bodies of waters, both salt and fresh. Water is transformed and reformed by temperature. Heat causes ice to melt, which changes the form from a liquid to a solid, then from a solid to a gas. The cold, which would be a lack of heat, causes water to reform into its other states of matter. Condensation is when gaseous water molecules turn into liquid water molecules. Precipitation is when water is in the form of rain, sleet, hail, and snow, and it falls from the atmosphere onto land in bodies of water. Infiltration or percolation is the downward movement or passage of liquid through spaces of porous material such as soil. Transpiration is the process in which water is absorbed by the root systems of a plant, then moves up through plants, passes through pores in their leaves or other parts, and evaporates into the atmosphere as water vapor. Evaporation is the conversion of a liquid into a gas.
That's all, folks.